Okay, let's find the slope of x squared plus y squared, quantity squared, is equal to x minus y, quantity squared at 2 points specific. And, well, obviously, to be able to find the slope, we got to be able to take the derivative. Okay, so let's start here on the left. If we're going to take the derivative of anything to a power, we're going to drop that power. So x squared plus y squared now to the first, and then times the derivative of the base. So it'll be 2x plus 2y dy dx. Okay, and on the right, we're going to drop the 2 down front. It's now to the first power, and then times the derivative of the base, which is 1 minus 1 dy dx. Okay, let's finish cleaning this up some more. So we have 2x squared plus, or you know what, so it makes it easier on ourselves. You notice how we have a common factor both on the left and the right? It's going to be 2 times this side and 2 times that side. Let's just go ahead and knock off the 2 so we don't have to worry about taking care of it later. That'll make it a nice little simple. Okay, so let's just FOIL this left side then. We have 2x cubed plus 2x squared y dy dx plus 2xy squared plus 2y cubed dy dx is equal to, looks like x minus x dy dx minus y plus y dy dx. And then from here we just need to kind of move some terms around. Let's put all the dy dx terms on one side. So let's move that one over, let's move that one over, and then all the ones let's move them the other direction. Okay, so let's see if we can factor 2. Kind of kill 2 birds with 1 stone. So 2x squared y plus 2xy squared. Move that guy over, it becomes positive, so plus x minus y. All of those had the factor of dy dx on them. And then if we go to the right side, so I had an x, a minus y, minus 2x cubed minus 2xy squared. All right. So all in all, the derivative then is x minus y minus 2x cubed minus 2xy squared all over 2x squared y plus 2xy squared plus x minus y. And before I go on, just because I did several steps at once, I'm going to go back and just double check real quick here. Is going down line by line. That one had a dy dx, that one had a dy dx, that one, and that one. So we have 2x squared y. That should be a 2y cubed right there. Okay, good. It's always nice to find mistakes before you start getting involved in the problem. Okay, so there's a 2y cubed there. That moved over, so positive x and a minus y. Okay, that's great. And then on the right, we had an x, a minus y, move that over, so minus 2x cubed and a minus 2xy squared. Okay, good. So now let's fix up the last little bit. Didn't hurt to catch your mistakes, right? It's always a good thing too. Okay, now from there we just need to go back. That's technically the derivative, and now we just need to go and find it specifically at points. So dy dx, the derivative evaluated specifically at 1, 0. That's kind of how you read it. So the derivative at 1, 0, it's going to be 1 minus 0 minus 2 times 1 cubed minus 2 times 1 times 0 cubed over 2 times 1 squared times 0 plus 2 times 0 cubed plus 1 minus 0. Okay, so simplifying all that out, we'll get a slope of, let's look at the top, 1 minus 2 is negative 1, because that all goes away, that all goes away, that goes away, over 1, so slope of negative 1. Okay. Evaluating the derivative, so dy dx at, oh, I lost my other point, 1, negative 1. Okay, I'm plugging this in very carefully. So 1 minus a negative 1 minus 2 times 1 cubed minus 2 times 1 times negative 1 squared all over 2 times 1 squared times negative 1 plus 2 times negative 1 cubed plus 1 minus a negative 1. So we'll go plus 1. Okay, so cleaning this up, see 1 plus 1 is 2. 2 minus 2 is 0. And then we'll get a negative 2 there, so it'll be negative 2 over, give myself a little bit more room down here in the denominator. We'll get 2 times negative 1, so negative 2 minus 2 is negative 4, plus 2 is negative 2, so we get a slope of 1. And there's my two slope values. Okay, example 7. Okay, with this example, they're wanting us to do a couple things. First of all, we want to make sure that negative 2, 1 is for sure a point on this curve. So we're just going to plug it in and make sure that I get 0 equals 0. And then we're going to find two things, both the tangent line and the normal line. Okay, so the tangent line is the one that kind of runs almost parallel to the graph at a very specific point. And the normal line is the line that runs perpendicular to the graph at that very specific point. Okay, so that's what we're going to find. There's two different things. But first of all, let's go through and do the verification part. So let's see. We have 1 squared minus 2 times negative 2 minus 4 times 1 minus 1. Does that equal 0? So 1 plus 4 minus 4 minus 1, 1 minus 1, 4 minus 4 equals 0. Checks out. Okay, so we're good to go. Now, that obviously was not necessarily a waste of space, but I'm going to utilize my space properly. Okay. First of all, well, for us, in order to be able to actually find the tangent line and the normal line, we've got to find the derivative, because the derivative is the only way we're going to get the slope. Okay. So going up to our main equation, we're going to get the slope of 2y dy dx minus 2 dx dx, which is just 2, then minus 4 dy dx minus 0 equals 0. Okay, so obviously that has no part to it. And if I look at 2y minus 4, and then factor off the dy dx and move the 2 over, we can kind of finish up this all in just one more step. And reducing. So making our lives just kind of a little easier as possible. So 1 over y minus 2 is specifically the equation we're going to use to find the derivative. Okay, so two different things I want to know. I want to know the slope at negative 2, 1, first of all. So let's find dy dx at negative 2, 1. So it's going to be 1 over, we only have a y value here, so 1 minus 2. So 1 over negative 1 is negative 1. So it's telling me that at this point, specifically at negative 2, 1, if I was going to graph this graph, the slope there is declining at a rate of negative 1 over 1. Okay? So here's how we're going to find the tangent line, first of all. To get the tangent line, we need to know, first of all, our slope is going to be negative 1, and then we have our point negative 2, 1. Okay, so plugging this in, we're going to get y minus the y value is equal to m times x minus the x value. Okay. Or y is equal to negative x minus 2 plus 1 be minus 1. So there is the equation of the tangent line. And the only difference that we have to do for the normal line is the fact that we can't just use the slope as is. We have to use the perpendicular slope. So it's almost, I'm going to write it like that. M perpendicular is the opposite reciprocal, so now it's positive 1. Can't really take the reciprocal of 1, it's going to be 1. And we're still going to use the point 2, 1. And then doing the same point slope form like we did the last part, we're going to get y minus the y value is equal to m times x minus the x value. And then this is going to give us a normal line of y is equal to x, 2 plus 1, so positive 3. Okay, so this is the tangent line. I can say y, whoops, I was going to do a little variable down there. Let's do y sub t as our tangent line and y sub n as our normal line. Okay. And one more example and we'll be done with this lesson.